Hey everyone, so if you're coming from the world of React Native, you already know your way around building some incredible apps. But the web, well, that's a whole different playground, with its own set of rules and, honestly, some amazing opportunities. Today, we're going to take a journey from mobile to the modern web, and we'll check out the patterns and architectures that power some of the biggest sites on the internet. All right, let's get into it. First up, we'll close the gap between React on mobile and the web. Then we're going to zoom way in to the component level with a deep dive on some really important web-focused hooks. After that, we'll zoom back out to the big picture, the architectural level, to really understand micro-frontends and the tech that makes it all happen, module federation. And finally, we'll connect all the dots and see how it all fits together. So you're ready to jump into web development with React. And the great news is your core knowledge, components, state, props, all of that is 100% transferable. But the environment you're actually building for, well, that changes just about everything. It's a question you're probably asking, and the answer is kinda. Yes and no. You see, while the heart of React, the core principles are exactly the same, the body it lives in is completely different. Let's break down what that really means. Okay, so what's really going on here? In React Native, you're telling the phone, render a native button or render a native view. On the web, you're talking to the browser's DOM, which is a totally different beast. Instead of hitting device APIs for, say, the camera or your contacts, you're using web APIs to do things like fetch data or mess with the browser's history. And this last point on architecture, this is a huge deal. Native apps are usually one big single thing, a monolith. But on the web, we can build our app as a collection of smaller, independent apps that all work together. And that's not just a minor tweak, it's a fundamental shift that unlocks a ton of power. Okay, let's zoom in from that high-level view down to the tools you'll be using every single day. You're already familiar with hooks, I'm sure, but in the web environment, where the DOM can be a major performance bottleneck, using them correctly is absolutely critical. We all know and love useState. It's perfect for simple, independent stuff, like whether a modal is open or what's in a search box. But what happens when your state gets complicated? Think about a shopping cart form. When you change the quantity of an item, you also have to update the subtotal, and you might need to recalculate the shipping cost. All those pieces of state are connected. That is the perfect time to reach for useReducer. It lets you group all that related logic into one predictable place. It's the difference between juggling 3 different things and having one neat, organized system. Think of useEffect as your bridge to the world outside of the React bubble. On the web, that means, well, just about everything. Fetching data from an API, setting up a real-time connection with a WebSocket, or even just working with a third-party library that needs to directly touch a piece of the DOM. It's the hook that handles any side effect that has to happen after React has done its job and painted your component on the screen. So, listen up, because this part is crucial, the dependency array. If you get this wrong in a big web app, you can create performance nightmares. Endless network requests, laggy UIs, you name it. An empty array means, hey, just run this once when the component first shows up, which is perfect for fetching initial data. No array at all? Super risky. It runs on every single render. But putting dependencies in the array is where the magic is. It tells React only rerun this code if this specific thing is changed. Getting this right is one of the keys to a fast, snappy web app. Okay, useMemo versus useCallback. This one trips up everybody, but it's actually pretty simple. useMemo remembers, or memoizes, the result of a calculation. So if you have a really expensive operation, like filtering a massive list of data, you can wrap it in useMemo so it doesn't have to recalculate on every render. useCallback, on the other hand, remembers the function itself. This is super important for performance because every time a component re-renders, it recreates all of its functions. If you pass one of those new functions down to a child component, it can cause that child to re-render unnecessarily. useCallback breaks that chain. All right, so hooks give us this amazing fine-grained control to optimize our components. But what happens when the problem isn't just one component? What happens when the entire application, the whole structure, becomes the bottleneck? When your code base gets so big that just building it and deploying it is a massive headache. That's when we need to zoom back out and rethink our architecture. And that's where micro-frontends come into play. And this quote is just the perfect analogy. Instead of building one giant, monolithic thing where everything is tangled together, you build small, independent, self-contained pieces.
Each team can own their Lego block. They own their features, they own their deployment schedule, and then you just plug them all together to create the final application. It's a totally different way of thinking about building for the web at scale. Let's make this feel a bit more real. Imagine a big e-commerce website. You could have the search team using React and shipping new updates every single week. Meanwhile, the catalog team, who handles product details, might be on a totally different stack, like Angular, and they deploy once a month. The checkout team could be using Vue, and the marketing team can push new content pages every single day with just plain old JavaScript. Each team moves at its own pace, using the tools that are best for them, and nobody blocks anybody else. So why does all this matter? What's the big deal? Well, independent deployments mean the checkout team can push a critical bug fix right now without having to wait for the search team's big new feature. It gives teams real autonomy. It speeds up development like you wouldn't believe, and it just makes the whole system easier to scale and maintain as you grow. It's all about moving faster and safer.
Okay, this all sounds great in theory, but how do we actually get those Lego blocks to talk to each other? Well, the magic behind all of this, the secret sauce of modern micro-frontends, is a technology called module federation.
The key phrase here, the one you really need to lock in, is at runtime. In the old days, we'd share code by publishing a package to NPM, installing it, and bundling it at build time. This is different. This is about one running application dynamically loading code directly from another running application, live, right there in the user's browser. It's a total game changer. The whole setup is actually pretty simple to get your head around. You have a host application. Think of that as the main shell or frame of your website. And then you have your remote applications. Those are the Lego blocks. A remote app's configuration basically says, hey world, I'm exposing my button component for anyone to use. And the host app's config says, okay, cool, I know where to find that remote, and I'm going to consume that button. So what does this look like in practice? It's surprisingly simple. Step 1, the remote app declares, hey, my button component is up for grabs. Step 2, the host app says, got it, I know where that remote app lives. And step 3, the host just uses standard React stuff like lazy and suspense to dynamically pull in that button from across the internet and render it, just as if it were a local file. We've gone way down into the nitty-gritty of hooks, and we've soared up high with architecture. Now, let's bring it all back together and see how these pieces create a really powerful, modern way to build for the web. And this right here, this is the ultimate payoff. Just think about it. The checkout team finds a bug in their payment button. They can fix it, deploy their tiny little remote app, and that fix is instantly live for every single user. The main host application doesn't need to be touched, it doesn't need to be rebuilt, it doesn't need to be redeployed. This just dramatically speeds up how fast you can deliver value.
So, what are the big things to take away from all this? First, hooks are your precision tools for making individual components fast and efficient. Second, micro-frontends are the architectural blueprint for building huge, scalable applications that don't fall over under their own weight. And finally, module federation is the incredible tech that glues it all together, letting independent teams build one seamless product.
So I'll just leave you with this question to think about. As your web project gets bigger, as more teams get involved, start thinking about these patterns. That jump from a single monolithic app to a composed modern web architecture can seem big, but it might be exactly what you need to scale. Thanks for tuning in.